Okay. Hello, everyone. Hello, folks. Started a new stream. Yeah, on today's session, we have a couple of problems remaining to be solved. So I'll be trying to fix them. I think I forgot to start my music. Yeah, let me try this. Make it a little bit less annoying. So, okay, music up. Checking stream. Checking the settings. Yeah, everything seems to be good. Cool. Very nice. Okay, so I will need to apply our tags. So bit manipulation. We'll need to search for difficulty. Change sorted by acceptance, and we have like 6 problems to solve. So if we're looking here, we have like 124 out of 771. So I did start the year around like 50 problems or so. So during the latest streams, I managed to solve 70 problems or more, and daily I'm solving the problem. So if it's a medium, hard, or easy. Cool. So I have a couple of days and I'll receive my February badge. This will be my second month where I was trying to solve every problem. Yeah, let's check, find the difference. Let's go one by one. Maybe we'll manage to solve everything today. That would be a very nice achievement. So I think we did stop here last time. Okay, so you're given two strings, S and T. String T is generated by random shuffling string S, and then add one more letter at a random position. Return the letter that was added to T. Okay, so this problem, I think it's easily solvable by just trying to XOR everything. So yeah, let me show you the idea on the drawing board. Using an XOR operation, we may try to, let me copy an example first. Looks like I need my flame shot. So take a screenshot. So let's use these two examples. Copy this, paste it here. So my idea here would be something on those lines. So we have like our first string A, B, C, D, and we have our second string, which will be A, B, C, D, and then we have the E letter. If you divide both of them, because we do not know the position itself, but what we do know, it's that it's only one letter, and we know a property of XOR, or exclusive OR. If we XOR A and A, the output will be like a 0. They will nullify each other. So we may apply an algorithm, like we can get all the letters here and XOR this string by all the letters above, and the remaining one will be only E. So that's kind of my idea on how to implement it. But we may have some troubles, or let's say difficulties to implement it. So first, I guess I'll use the binary form, or as bytes. So I'll have like A, B, C, D, E as bytes. And we can do a similar thing for the first one. So what I'm trying to do, it's kind of a little bit interesting because I need to test it. I'm not sure if that works or not. I'm not sure how does it work when we're trying to use strings. So yeah, the simplest way is to do a short example. Cargo new. So let me check what would be the name. Find the difference. Okay, so find the difference, and that would be a lib. So let's go there. Find the difference. Let's go inside. Let me zoom it for you guys to be able to properly see everything. I'll be copying this part. So we'll have a struct solution. And let's add a couple of scenarios. Most important, ABC, ABCDE. No, actually it's ABCD, and the second one would be ABCD. So the solution will be like E for this case. Yeah, but we'll need to make them strings as defined in the requirements. Okay, so we do have this part. Here we'll need to properly destructure everything. So it'll be like S and T. So here we'll have like a solution, find the difference, and let's pass S and T. Yeah, let's do a short test. Yeah, our scenario worked fine. So what I want to do right now, I want to check what happens if you have like a string S, let it be like AB, and I will try to XOR this. So let me print line this part, and I do S like XOR and B. So I'm expecting to have A, but yeah, actually we cannot XOR this, so that's interesting. So how can we do it? Okay, I have an idea. Yeah. Okay, so my idea would be this stuff. So kind of will need to XOR everything, but actually we do not know exactly what's the missing letter. So what we can do, it's kind of transform everything as string, where easier will be as binaries. Yeah, as bytes. Join these two together, where in our case we can do a chain, where yeah, actually it will be a chain. So I want to have like A, B, C, and D here, and as well join the second one, like A, B, till we have E. So we will start XORing the entire vector, and they will nullify each other, because this A will be nullified by this A, this B will nullified by this B, this C by this C, and D, and so on. So the single stuff remaining in the vector will be E. So we'll have our result and our response. So let's try to code it. But before that, let's see what will be time and space complexity of this solution. So what do we need actually? We will need to iterate once both the size of A and B. So we'll need to go one by one. So if it will have like n plus m, or n plus 1. So this will be a big O of this, where n will be the size of the string, first string, and this part will be the second string, but we know it has a letter more, so this will be like this plus 1. So this time complexity of this algorithm will be like big O of n, and extra space. What will we need for extra space? I guess we'll need to join this things into new vector, and for that we'll need extra memory. So still it will be the amount of variables, or the same n plus 1, or big O of n. So it's a pretty fast algorithm. Yeah, let's try to code it. Yeah, I'll code it here first, and then we'll move it on the other side. So we have s as bytes. Then let's create an iterator. Then let's chain this with t as bytes. Iterator. Does it work like that? I don't know. Yeah, let me do a to-do here. Be sure that this works. And then we'll need to fold everything. So we'll start at 0. And inside we'll have a mutable accumulator, and then our, let's say letter. Let it call letter. Chain iterator, maybe like this. I'm not sure though. As bytes, what does it return? So it returns a slice. So maybe I don't need this actually. Maybe I can do it right away like that. I'm not sure though. Let's see. Let result. So result in our case, it will be yeah. So probably we'll need to as iterator. And here iterator t as byte. Yeah, actually it managed to do it. So we'll have like accumulator, and we'll be XORing it with the letter. And let's return this. And result will be an U8. So let's return this, or actually we may not necessarily need to do it. So we can do like this, and here as char. So that's it. That's it. Actually, this should work. Yeah, and indeed it does. Yep. Let's copy this and run it on LeetCode. Oh, cool. So first working, second working. So let's submit. Awesome. So we do have a fast solution. Looks like the fastest out there, which is really, really cool. This means we did learn something during this journey of trying to understand how bit manipulation work. Yeah, awesome. This solved. Move on. Minimum operations to collect elements. Yeah, let's check this one and see what this one is about. You're given an array nums of positive integers and an integer k. In one operation, you can remove the last element of the array and add it to your collection. What? That's not very clear. Minimum operations to collect elements. You're given an array nums of positive integers and an integer k. In one operation, you can remove the last element of the array, like using pop, and add it to your collection. 1 to k. Okay, not sure I got it. After for operation, we collect elements 2, 4, 5, and 1 in this order. Our collection contains elements 1 and 2. Okay, so in this case, the answer is 4. Interesting one. Let's brainstorm it a bit on our whiteboard. We'll be copying these two examples. This will not need anymore. And let's check it here. Okay, so we do have this vector. So we have the vector of 3, 1, 5, 4, and 2. And we have k equal to 2 in this case. So I assume that they want to collect everything till till k, so including k. So we'll need our goal. So let's call it this to be like a goal. Our goal to have these items. But how can we know if we did collect them or not? Because we may go like in a simple manner. So we'll be popping this first. So we'll have like 2. So 2 will be removed from the goal. We'll have like 4. It's not on our list, so we don't care. We have 5, not on our list, don't care. We have 1. And 1 it's 1 and it's fulfilled. So we have like 2, 4, 5, and 1. So we do not care about this, but we need 1 and 2. So the output will be 4. Yeah. There is no choice here, so pretty much what we need to do is just to execute the algorithm and we'll find the option. Because there's nothing here to choose. I mean, to include, not include. So 5. But one thing I wonder how this is related to bit manipulations. This part is unclear. Okay, so yeah, let's try to design an algorithm. So for k part, we know that yeah, one thing I would like to check, it should start with 1. So probably we'll create like a bucket of size k, and we'll put everything being 0 at first. We'll put everything to be 0 at first. Or do we need this bucket? Yeah, maybe we do. Because I'm thinking we can go this approach, or the other approach may be like if we found an item. Yeah, but do they tell that they are distinct? Because that's the trick. Positive integer. It's not necessarily distinct, so we may have duplicates, and then my other solution whereas like I need to collect elements. Okay. The input is generated such that you can collect elements 1 to k. So we can collect them. Okay, so let's see. Use an occurrence array. Yeah, I was planning to do that. Iterate over elements in reverse order. I mean, yeah, I can do that as well. If the current element numSi is not marked in the occurrence array and numSi is less than k, then mark numSi. Keep track of how many integers you have marked. Return the current index as soon as the number of marked integers become equal to k. Yeah, this is one way to implement it. I was thinking a little bit different one. But yeah, that would be an occurrence array. So I indeed can go backwards. Yeah, but I was intending to go backwards. So have, for example, 2. Here we can put index 1, 2, and we can have a copy of k, or even we can decrement k by 1. So k will be equal 1 in this case. We'll do -1. So we move on. 4. We don't have 4 in our list. We don't care. 5. We don't care. And 1 will be this one. And k will be 0. So we've marked everything. And if k became 0, then we can exit. So have like a counter. So let's do something on those lines. So we can do like we'll have a variable called counter. We will initialize it at 0. And then we'll do each item in reverse order. In let's say nums.reverse. So we'll do if item, actually not item, but if let's call it occurrence array or bucket. Let me call it bucket. So bucket will be a vector. Everything at first will be 0 and size k, because we'll need everything from 0 to k, including, I guess. Or I can just use -1 to not bother about this starting at -1. So we can do if bucket, actually, if bucket of it -1 it's greater than 0. This means, or it's equal to 0 in this case. Then we'll increment it. We'll do +1. K will decrement it to 1. So that would be our small algorithm here. But yeah, actually I'm thinking, do we need in this case to have a counter? Because I may go with enumerate. I may not even need to go with the counter. I may use like, yeah, probably I don't even need to go with reverse. I can use like pop. So I'll just have the counter. Okay, so yeah, more or less that's the algorithm. Probably it will be easier to write it down than to spend time here. So yeah, let me yeah, I'll try to write it right here. So let's create first our bucket. Zero k. I'm thinking this will not work. They will ask me to use a new size for this part. Yeah, next stage, let's create our counter. And let's do while let some value, we do like nums dot pop, because I don't want to deal with the unwraps, but this is not mutable, so I will not be allowed. I will need to mutate it first by doing a clone. So we'll be writing this part. Now let's write our checks and think on how we can improve them. So first case, we may have a value in our bucket. So let's assume we have 0. So yeah, if a bucket of value, in our case value, it's an I32. So as use size, we'll need to transform it. We'll do -1 because we know by constraints they start at 1. So if this is 0, then we should, yeah, we'll need to mutate k as well. If this is 0, then we'll do k -1. This means we found something in our bucket. Yeah, let's mark that value as use size -1. We'll do an increment +1. We actually do not care if it's 1, 2, or more. We just need this to be sure that we found all of our elements. So we decremented it, k -1, bucket +1. So if k became 0, this means if k became 0, this means we found our solution. And we can break because we don't need to do anything else. What happens if it's not greater? Then we don't care. We'll not. We actually can increase the bucket by 1. But do we care about that? We don't. 1, it's good. So if k became 0, we can break, and we'll need to counter +1. So we'll need to increment our counter. Here we'll need to return counter as I32, or it is I32 already. Yeah, maybe we can create it as I32 right away. So I guess this should work. We have a runtime error, so maybe I have some bugs here and there. Okay, so yeah, let's move everything in VS Code and try that. Okay, so I'll need a new one. So let me remove this. Cargo new. How this stuff is called? Minimum operations to collect elements. Okay, so minimum operations to collect elements. I forgot to add it as a lib. Yeah, so let's go inside. Yeah, probably I'll move this screen here and move this on this part. So yeah, no, actually it's not right. This I'll move here, and here I want to move my whiteboard. So let me check. Yeah, this looks right. So that's correct. Okay, so here I should have like 2 of them. Let me zoom it. I think I zoomed it too much. Let me copy this part, paste it here. So struct solution. And we'll need to add a couple of scenarios. So I have my code tool to generate some scenarios. So 2 and output should be 4. Actually, not like that. The output should be 4. Okay, so let me copy the inputs. And probably I can even generate the next one. So here use a 5 and the output should be 5. We don't need this. Actually, we do. Yeah. Okay, so I do have my test cases added. So let's run. Okay, it doesn't work for now because I need to destructure this. So it'll be like nums and k. And here we'll have like solution, main operations, and having like nums and k. Okay, so we have problems like index out of bounds. The len is 2, but the index is 3. Okay, so what is our mistake? Yeah, actually we will need to check if value is less than k. But this is actually also known as JavaScript. This will not work because we are trying to set a specific variable, but we don't have the value for the variable. So k being 2, but actually less or equal to k, then it should work fine. Okay, so we have like left being 3, but we have 4. So where is our problem? Yeah, our problem is that we already start by popping the item, so we should start at 1, not at 0. Okay, so cargo test. Second scenario doesn't work. It's okay. Okay, so let's check how many pops we do here. Okay, so maybe we should do it like this. So we increment and then we break, because we may prematurely break in some cases. Okay, yeah, so that was the trick. So looking now, what's the algorithm here? Worst case scenario will be popping all the elements from our vector. So time complexity would be like big O of n, so it's a linear. Space complexity, we use this bucket, which will be like the same. Worst case scenario, if k is equal with nums len, then it will be like big O of k, which we can tell like also linear. We do not use anything extra. So space big O of n and time big O of n. Can we do it faster or better? Because we may need to think of an bit manipulation algorithm. This should be like a bit manipulation thing, but we do not do anything with bits. So so how can we do it with the range? with the bit manipulation range. I do not see a solution for now. Okay, so let's copy this and run in LeetCode first. And then we'll see, maybe we can figure out something. Okay, so we have a wrong answer. Case 3 being wrong. Yeah, let's check this one. So K3 output should be 4. So yeah, let's try this. So similar approach, but for K3 we need to have like 4. Closure lang. I mean Closure.js, or not sure I know. Yeah. By the way, welcome Unwarekare. Welcome aboard. Closure lang. I don't even know what's this about. Let me check. Closure lang. Oh, yeah, I mean I never tried it. It's quite an old one, Closure Java API. Or maybe it's a different thing. Yeah, maybe I'm confusing it with Closure.js. A long time ago, there was like sort of transpiler called Closure.js. Closure script. Not sure if they're related. I see it's the same logo or something. But it was popular at the time, like 6-7 years ago. But I never get deep into it. Maybe it's cool. Feel like if it's Closure, maybe that's a purely functional programming language. Closure is nothing if not practical, and Closure script is no different. Okay, dependency. So if we see some examples, guides, yeah, let's look at some guides. Yeah, I don't know personally. If it's not a buildable language or compiled language, does it make any sense to spend time on it? I mean, it does make sense if it's a Python or a mainstream one, but if this is not a mainstream one, I personally am not sure if I would spend time learning it. Hello, Abdullah Ibn Noor. Yeah, welcome aboard, welcome to the stream. Trying competitive programming. Yeah, I don't feel like competitive programming it's language related. Most of the time you can do the same things in Python or any other language because the techniques are different. So JS may be good. Most of the competition they have like yeah, I guess if you want to, you cannot necessarily compare a compiled language with a non-compiled language like JavaScript comparing to Rust. Rust would be much faster. But for competitive programming, I feel like the algorithm is most important and not exactly the execution time. Because, for example, on LeetCode, they compare JavaScript with JavaScript and Rust with Rust. They did not compare inter languages, because that will not be fair. I mean, Rust being a low-level language would be faster than JavaScript most of the time. No, this one is pretty powerful, like Rust. Yeah, I didn't check deeply, to be honest, on what I got it. I don't know. I cannot give an opinion. So I heard about it, but Rust is way than enough for me. It's too challenging. I have troubles learning how to do Rust. So trying to learn to write like fast code, smart algorithms, leverage all the features of Rust. So for this, I'm practicing using LeetCode. But yeah, getting back to Abdullah, I feel like just spend time learning algorithms. They will not change much, and very likely if you'll provide a solution, it will be like not necessarily in I mean, not the language will be the trouble, so the algorithm itself will be problematic. So I can give you an example being like advent of code. So during advent of code, they do not care about what language you are using. So they provide you an input file, and they give you the description. So you need to provide back an output. So they give you the input file, and you run your program locally, and then you send back the output. So yeah, if you have like a fast algorithm, it will be, let's say, 31 microseconds in Rust. In JavaScript, it will be like 100 or 150 microseconds. But this is not really important for the outcome, because unlikely you'll be able to leverage those 80 microseconds to post the response faster. So you'll have a second or so delay. I am a beginner in CP, so should I give my time in, or just give my time in learning framework and create good project? Just what will be your suggestion? I'm completing graduation in, so I'll go and data structures. Okay, so yeah, if you want to find a job, very likely they will ask you some project experience, so you'll need to have some frameworks or some projects on your belt. So for that, spend time creating some dummy projects, your own projects, because this may be very useful during interviews. So you can tell to the interviewer, okay, so I have this experience, only algorithms. I tend to, so it depends. So at my current job, I will hard push on algorithms when I see a senior guy than a junior guy. So it's a little bit counterintuitive, but most of the seniors, they have like very good knowledge of frameworks and architecture and different, let's say, design patterns and so on. But one of the weakest points being data structures and algorithms. So during interview, I push hard. But for juniors, I push hard on having that experience of knowing how to use a framework, how to structure. So first, spend some time to create, let's say, those projects. I feel like on the internet, you can find courses, build 10 projects with this technology and so on. So that would be okay. So yeah, Abdullah, just start having a portfolio, or create a short portfolio where will be okay. So are you so next question, Are you pretty sure about memory management in Rust? How can you catch a memory leak? Yeah, that's funny, but memory leaks are caught right away by compiler in Rust. You cannot write code that will leak memory. So that's the, the trick about Rust. You cannot dangle pointers. Also, every data structure needs to be known at compile time, or you should send some or use some smart structures like reference counters and so on if you are passing and using multi-threading. But in Rust, it was built to not have issues with memory leaks. So if your code compiles, you are like 90% sure you'll not have troubles with memory, because all the bugs are caught at the compile time. So actually your program will not build. So this is why, but they ask you to build it in a very specific manner. It's not easy, to be honest, to write Rust code. Sometimes it's very unusual and tricky. R, I think it's math related, so it's used mainly for science, like physics, math related stuff. So it's popular for this kind of things. Yeah, let me copy this and check what's my problem there, because it looks like it's not correct. Okay, so this should be 4, this is 4, and this is... Okay, so that's a different input. Okay, different input. Yeah, last scenario did not work properly, so let's check why. Yeah, we have two times 3, so that's a case where I wanted to guard against, but not sure if I succeeded. So let's let me debug it. Okay. How do JIT work in Rust? Good question. I'm not sure. It's too complex for me to understand. But if you are talking about specific memory related stuff, it has the concept of a lifetime, and each variable, if it's enclosed in a scope, once the scope is finished, it will be released internally. So at runtime it will be released. So let's assume I will be creating here a variable called test value 1. This test 1 will not exist outside the scope of this bracket. So this is like obvious. Many languages does this, like JavaScript including, but actually it will be marked by a garbage collector to be removed, and on the next cycle it will be removed from memory. But in Rust, this will be the lifetime of this variable will be until it gets to inside this while loop. Outside it will not exist, and it's getting more complex and complex. If, for example, you have a variable bucket, which is like a vector. If I'm using I create a function, so a function like I don't know, fn test and use vector vec or v, let's call it v. So this will be like a vec. Let me create a type and so on. Returns like an i32, one item, I don't know, max or min or something like that. If I'm using this, I'm calling this test function with bucket. it will start telling me later on that I cannot use this anymore. Yeah, this will not compile. Cargo new, cargo build. Yeah, actually I need to return here v of 0 or something. Okay, v of 0, wherever. Here it will tell that the variable was moved. What this means, it's that if I'm not passing it as a reference inside this function, the owner of this variable will become the test function, and this v will be available until this function is executed. After it will be destroyed. So if I'm using it later on, this is not possible. So it tells like a borrow of a moved value. So the bucket part was moved. So this is like a Rust compiler understand that this was used already or removed or consumed, probably consumed was the better word, and it will not allow me to do any other operation later on, which is completely super annoying when you start coding in Rust. At first, this stuff annoyed the hell out of me because I was not understanding how in the world I can move on. But later on, you learn some patterns on how to write Rust. So in this case, I'll be passing this as a reference. And then I'm fine. I'm good to go. So I can continue. But here actually it tells that I'm passing this the variable, not the reference part. So I'll need to correct it using this form. And there are many scenarios using lifetimes. When you work with the strings, for example, if you return something else inside a function, you'll need to provide a lifetime. So syntax is of this form, you may see. So it's getting complex very rapidly. But Rust compiler is extremely smart and can figure out all these things during compile time and notify you. So your code will not compile if it has like memory leaks or potential, let's say, issues and bugs. But this is a huge topic. I mean, I just get into it. I'm just getting comfortable into writing Rust. All the theory behind it, and I've read it 5 or 6 years ago, then I forgot, and now I just want to not have only theoretical knowledge, but mainly to feel the language, to be internalized in my mind. Okay, I think I wanted to debug this stuff. So we have this. If value is less than k, yeah, that's good. K being 3. So we increment this, we reduce k. We move on, value being 1. Wait a second. I think, yeah, I'll need to increase the counter. So value, yeah, I want this to be down a little bit. Don't need this. So k being 2, counter being 1, and value being 1. So we move on. Next one being, what's the value? It's 3. And k in our case. Oh my god. Yeah, kind of I'm mutating it, so let me do it differently then. So instead of this, I'll use here like maybe lives, not necessarily lives, maybe operations. Okay, let's call it ops, operations. So yeah, we'll be reducing ops, but so I'll need to check ops, not k. So that was the problem. Yeah, so this was the problem, and now let's check the other tests. Everything good. Copy again. And the behavior of the program can be modified at runtime. Behavior of the program. I mean, for sure, yeah. I mean, you can have like different branches and different structures, but let's say during compile time, it will not allow you to go into weird scenarios. So let's tell a simple, yeah. Let me finish with this one because I just want to finish this. I had the goals to finish with this problems today. Okay, so this worked, and let me refresh this page. We have a couple more, so yeah. Let's assume you write in JavaScript. Not sure how comfortable you are with the JavaScript. But let's say in JavaScript you can create a vector or an array, and you can push any kind of things there, like a string, a number, an object, I don't know, a different other data structure, a boolean, let's say, or true false, undefined, not a number, all kind of JavaScript types. So that's possible in JavaScript. In Rust, you'll never be able to do that. So in order to be able to do this, because it's possible to do this in JavaScript, in Rust, you'll need to create an enum and then define all these types. So for example, variants. Actually, they are called variants. But let's say. So I want to have like strings, and this will be like a string type. I want to have like a number. So for example, call it number, and this will be like an i32 type. And this, and I want to have like a boolean, and this will be like a bool type. I want to have a different stuff like undefined doesn't exist in an option. So yeah, closest thing will be an option. So let me call option, and this will be like an option type. But we need even to specify what kind of option should be, what type of the option. So option of u32. And then you'll be able to create a vector like this. But you'll need to provide all the variants. So it will be like variants, and then string, and then here inside you'll provide a string. To string, stuff like this. So you'll be able to do stuff like that. So yeah, there are options, but you'll not be able. So how these variants will be mapped to memory, they will find the biggest one. So let's assume a string will be the biggest memory allocation, and they will assign this amount for everyone. For example, if this one is smaller, they do not care. So it will just map as the biggest, as this string. So you can have like different possibilities, different behaviors, works as well. But Rust at compile time finds the size and will will force you into writing the code in such a manner that memory leaks will not be there. But they're still, I mean, it's not possible to not have them at all, because simplest way, you just have a buffer which will be a vec, a mutable vect, and you start parsing a file, 3 gigabytes of data or 10 gigabytes of data, 1200. So you buffer everything, and they pile up in RAM. It's not necessarily a memory leak, because it's just the behavior of the program. I am sorry, kind of. I do not know exactly what I am means. But yeah, still you can leak memory in a form if you buffer too much and do not handle these parts. Okay, yeah. Does this stuff compile? Yeah, it does. Let me run again. Let's see with cargo Clippy. Can we do anything to optimize it? What? Yeah, it's never used because it's a library, and yeah, that one, this one today, it's a pretty interesting one. I think I have it somewhere. Cargo, what's the name of that one? Cheapest flights. But I think I've solved it using a Dijkstra algorithm. So it's kind of a classical Dijkstra style solution. But to be honest, if I have trouble solving a problem, let me show you. I learn a ton from one guy called LeetCode. So if I have trouble solving any problem, usually I go to YouTube, type in LeetCode.io. So this guy. So these guys post daily. And if, for example, I'm not sure if he did post today though. Maybe he did not. But he posts every day the solution of the problem and explains it very, very nicely. So that, I think that's the last one, but probably he sold it. So let me check. Medium, yeah, what's that of the day? It's this one. So yeah, one of the simplest way to do it, it's LeetCode.io, and paste it here. Yeah, looks like he sold it with the Bellman forward. Any algorithm which does the optimization, like finding the cheapest or the shortest path, would work it. So Bellman forward or Dijkstra, all of them work. But I like a lot how these guys explained, and I learned a ton. So I improved my skills on solving dynamic programming problems, and so on. So yeah, highly suggest to check it out. Okay, so let's get back to our stuff, because I really want to finish this list. But check LeetCode.io, very useful explanation. So reverse bits. Reverse bits of a given 32 bits unsigned integer. Know that in some languages, such as Java, there is no unsigned integer type. In this case, both input and output will be given as a signed integer type. Yo, thank you. Yeah, welcome. By the way, welcome aboard. So thank you for joining in. Press the like button, write comments, and if you have any suggestion on how I can improve this stream, would gladly do anything to improve it. Okay, so let's check this part. What do we have here? I think I think wait, I'm not sure I understand what should I do here. So in Java, blah blah blah, we don't care about Java. So reverse bits of a given 32 bits unsigned integer. So we are given this stuff. Okay, so I think so we should reverse one bit, or what's the trick here? I don't get it. What's this Java stuff? Yeah, I'm confused. So yeah, reverse bits of a given 32 bits unsigned integer. So we're given this input. Yeah, let me copy that. So if we paste it here, yes, sorry about this, and we have this output. Okay, so how was this reversed? Oh, it's not like inversed, it's reversed. That's cool. Okay, I guess X. Maybe we can use format. Let X be in format. And here we'll be doing 2 points B. And we have our X. But I forgot the structure. I think it's like this. We need like 32 B's. Then we'll do chars. Then we'll do iterator, then we do reverse or rev, then we'll do collect. Yes, something like that. Yeah, let me check it in just a test case here. I don't want to add a new scenario. So fn test reverse u32 rare. So we have this, we have like let, and let me copy this one. So we have this, but they are giving us not this, or they giving us, yeah, I'm not sure. So how should I, yeah, let's see. So let's try this first. Next, I'm trying this. I want to check the formatting part. N. Yes, something is not right. Maybe B. What? N. Oh, I need to provide the brackets. Yeah, got confused. So yeah, yeah, that I think is the structure. Yeah, let's print X now. Let's print X now. So we have this, but is it padded with? Is it 32 of them? Let me see. Yeah, I just want to have like x.len. So yeah, let's run this. So it's 32 actually. But it's not the same one, no? Wait, I don't get it. The input binary string represents the assigned integer 43 blah blah blah, this number. So return which is binary representation. Yeah, did I mess up? Did I mess up this number? No, it's not messed up. No, not sure. Not sure I understand. Okay, so I see that it's padded. So I have this part, but it's not like 32 items. I don't want to count it, but yeah, let me see how many items are here. Okay, so let seed. Not this test. So I have x and then len. Okay, so maybe I should do it like this to be sure. Yeah, it's a string though. Where's my zeros? I don't understand. Where are my zeros? Look here. So they're not padded. Okay, let's try. Not like this. Yeah. But how come this xlen is 32? Maybe it's not shown, or what's the trick here? So 5, 10, 15. No, it's, if I'm not mistaken, like 10, 10, it's 31 at least. I'm counting. Yeah, I'm confused. Okay, so this is for sure 32. That one, this one is not 32. How does Rust counts it like this? I don't understand. 15, 20, 25, 26. So I'm missing like 6 zeros. So I need to pad them somehow. Oh my god. How can I pad it? How can I pad it? Yeah, maybe use str pad. Okay. Yeah, I'm very confused here. How this? Let me try this. Maybe that's not that this part. Oh, look at that. So we have like 6 spaces, and then it's shown like this. So maybe okay, so let me check fastly how in Rust to pad right or left. Okay, Rust binary pad zeros. Okay. So fill alignment. So I think it's is it this? No, we kind of need to pass the value. Yeah, let's check that. I'm not sure that will work. No, it did not. Maybe if I'll put like 32, it should. Awesome. Okay, so now it worked. So that's the trick on how we can pad it. So once we have this, we need to revert it. So let's write the reversion logic. So we'll have like seeds, where's seed dot chars. Maybe can I use binary? No, chars is fine. Iterator. Then we do reverse, but I think chars is already an iterator, so we can do ref. And we can collect as a string. And now it's a tricky part. Because we need to transform this binary back into a number form. So I have my seed and my reversed. And reversed. So I don't need this. So let's run this. Yeah, I have a typo. Okay, so I think we have the right answer. Now we'll need to, from this binary string representation, we need to make it back in our correct structure. So how can we do that? What would be the most or the easiest way? One way would be like to start with a number, and call it number, which will be an U32, and we start at 0. And then we can get all values from here. We can pop them actually. So we can pop values from here. But do we need to pop? I'm not sure if we need to. We probably can just go in reverse order and set the specific value at the specific counter. So something like this. Okay, let mutable counter being 0, and then we do while. Yeah, I guess I'll need size burst.len. Well, size is greater than 0, greater or equal. Yeah, what I want to do, it's I want to set a specific bit for this number. So let's assume I've got like a size -1 actually. So let's assume I have like a seed of, yeah, this will not work. So let me do it like chars. Maybe even not even chars. Maybe I need to parse it, but that's too much logic. How can I do it in a straightforward manner way? Column U8s, no. Yeah, okay, so let's try simple way for now. So we'll do this, we'll collect, but we'll collect just as a vec of chars. So we have our vec of chars. Now we'll be able to do like reversed size, and this will give us a vec of, or yeah, probably even smarter way to do it will be like mutable reversed, and then we'll do, well, let sum ch being reversed dot pop. So we'll be popping in this order, and now we'll need to set the specific bit. So we'll need to match it. So it match bit being gh, or match that gh, and then we'll have either 0, then 0, and if it will be 1, like 1. So we'll have our bit, but let's call it an u8. Maybe that would be easier. So we'll now we'll know the bit. Now we'll need to set this bit, and I forgot the syntaxes. So probably now I'll check fastly my previous stream. Okay, YouTube. So I think I'm the first streamer watching his his previous solution in order to find how to do this. So I'll not need the commentary. Not this stuff. Not here. Not here either. Yeah, I should keep my problem solved somewhere. No, I think I solved, but where did I do it? Yeah, somewhere here should be. I recall this. Okay, so yeah, I've asked Copilot to do this. So that would be the logic to set a specific bit in a specific position. So then this means we have our number, and yeah, and now we'll need to pass the value, the bit, and we'll need to pass it how many positions. So it would be like number being this. But looks like something is not right. Okay, let it be U32. Okay, so we are setting the bit at a specific counter, but we need to increment the counter as well. So in the end, what we need to do is return the number. Okay, what don't you like here? Oh, okay, so yeah, it doesn't like that we need to exhaust. Okay, so I'll panic here. invalid bit. So yeah, this will not need. And let's try to run. And we've got this value. So does it look similar? Yeah, let me close my previous stream. I think it does. Yeah, it's that one. Okay, so we've got our algorithm. That would be it. So let me do this. Let me do this. And here we'll have like reversed. Instead of this will have X. Yeah, kind of I forgot to do this formatting part. So X will be this first. Instead of N, I'll have X, and then I'll do this part, then this, and I'll need to return my number. Yeah, I feel like this will work, though may not be necessarily the smartest ways to do, because this manipulation with strings and then reversing, probably it's not the right way. I think we can improve it, because we don't need to do that. One way we can do it's like setting in reverse order, because we know that there are 30, but yeah, we don't know actually. Yeah, we'll need this padding part. I was thinking if we go to our right board here, I was thinking, okay, so I can take my number, so let's assume it's 4. 4 will be like a 1 0 0. If I want to reverse it, I may set this bit to be at 32, this bit at 31, this bit at position 30. But actually this may work. Yeah, this may work actually. Yeah, so instead of going this way, why don't I refactor it to not do at all these operations? Because I don't need them. Okay, so we have a working solution, that's good. But we may improve it and remove all this extra space and manipulation with collection and stuff, because we don't need it. We can do it in one go. So yeah, I am thinking on going something like, so I have my counter, so this will remain the same. I may have a reverse counter, but I'll just use 32 minus counter, and that would do the trick. So I'll be doing this while X in our case is greater than 0. Then let last bit will be N1 or X1, so we're getting our last bit. X is a string. Okay, so yeah, let's do this X instead. Okay, so now we have the last bit and we have the position where let position will be 32 minus counter, and we can use our manipulation logic. We'll have like last bit and we'll have our position. So actually this should solve our problem. Do I miss anything? Yeah, I think I miss. I need to shift it right. X shift right 1 bit. Okay, so now We don't need this. We don't need this, and we definitely don't need this. And kind of we need to increase the counter somewhere. Yeah, X should be mutable. That's right. So yeah, we do this shifting and setting, and yeah, we go right and we increase the counter. Okay. Yeah, I declare it 2 times, run test. Yeah, this doesn't work though, because we are trying to shift with overflow. But maybe I'll use like position -1. Yeah, not here. I guess it's 31 because we start at 0. Yeah, that's the trick. Okay, so yeah, we simplified by a ton our algorithm. That will be a way smarter way to do it. So let's keep it in this form. Let's try to run it now. Yeah, I'll need to make it mutable. Cool, it does work. Okay, so we've got a pretty fast solution. That's cool. Is there any other way to do it? Lip? Yeah, I feel like it's the same approach. Exactly the same approach. Not sure why he used so many lines of code, because it's exactly this. I mean, okay, solved another one. Let's move on. We reverse this binary wedge. Yeah, let's check this one. Maybe it's a cool one. Oh, and we are an hour and 32 minutes already. Kind of I intend to finish with this challenge today. And we get into more complex problems. So let's see. A binary watch has 4 LEDs. Okay, 4 LEDs to represent the hours from 0 to 11. And 6 LEDs on the bottom to represent the minutes, 0 to 59. So 4 means 1 to, okay, yeah, that will work. So it's a binary form. So 12, is 12 like, no, it's like 16. Okay, so yeah, but we have only 12 hours, so should be enough. Yeah, okay, cool. And 6 LEDs, because we have 60 minutes, but we need to go with 64 last, or actually 32 last. So 32 plus 16, it should be 63. Okay, that works as well. Fine. For example, the below binary watch represents 4 for 51. Okay. Given an integer turned on, which represents the number of LEDs that are currently on, ignoring the PM, return all possible times the watch could represent. You may return the answer in any order. Turned on 1. Turned on 1. What does it mean though? So 1, like having 1 hour. or 2 hours? Not sure I got it. So how many of them are on? Yeah, that's an interesting one. And to put it in perspective, let's try to brainstorm it a little bit on the whiteboard. Yeah, I think today will be like really long stream, but hopefully we'll do it fast. So yeah, kind of we have only one LED on, so we have like 2 possibilities. We have like hours part, and if you go here, like being 1, 2, 4, 8, and I think that's it. So in binary representation, to be like 0, 1, 2, and 3. So we have like minutes, having like 1, 2, 4, 8, 16, and 32, being 0, 1, 2, 3, 4, 5. Oh, hi Nikita. Welcome aboard. Yeah, I did a longer stream today. I plan to do a longer stream today, so I've got into solving like problems, and currently trying to finish with my bit manipulation problems. I was at the beginning of the challenge, I was completely 0 in bit manipulation. Now I have a little bit of experience, and at the moment I'm trying to solve this one. So I think we solved the reverse bits a couple of minutes ago. Yeah, and now we are doing this one, binary watch. So it's a pretty cool problem actually. The idea is that you have a watch with LEDs, and you have like hours, some sort of binary form like 1, 2, 4, 8, and you have minutes. So some of them are turned on, and I need to compute. So for example, I didn't know exactly how many, but I need to compute all possible times given that 1 is turned on. So if 9 are turned on, it's not possible to have any time, I guess. But why? Because we have 4. Yeah, not sure why 9 doesn't work. Yeah, let me see. The hour must not contain a leading 0. For example, 0, 1 is not valid, should be 1, 0. Wait. I'm confused. The minute must consist of 2 digits and may contain a leading 0. Okay, so minutes are good, but hours are not. Yeah, that's a tricky one. So I'm trying now to debug it and see. Yeah, bit flags, exactly. So yeah, let's say we've got with hours. So if one of the LEDs are set for hours, so this. So let's say we can have 8, but 8 actually it's not possible because it should be a leading 0. So in this case, hours, we don't have any. None of the LEDs is possible to increment the hours if it's only one set, because for hours I guess we need two. But in this case, if this is set, we'll have like 0 and 0, 1. If this is set, 0 and 0, 2, 0 and 0, 4. Okay. I also will try to, to find a solution. If this is set, we have 0 and 0, 8. 0 and 16 and 0 and 32. So we do have these solutions logically. Okay, so they provide them here. So with minutes I understood. But with okay, so kind of one, it's also possible here. So yeah, okay, so here will be like a, but instead of this, we'll be writing like 1, 0, 0. So they are telling how to write the answer, not not the possibility. So how many do we have? So yeah, 0, 1, 0, 2, 0, 4, 0, 8, 0, 16, 32, and this stuff. So this seems to be a combinatorics kind of problem. Because let's assume I have a... Okay, so let me check here. Yeah, from 0 to 10. So one way to solve this problem is like if t it's 0, then we do this. If t is 1, then we do this. One way to solve this problem. But if we go with an easier approach, let's assume we have a 2 set. So let's assume there are 2 turned on. This means I'll need to find all possible combination like this and this, and then this and this, and then this and this. So I guess, but with 3 I'll have like using 3 for loops, maybe 4 for loops. No. Okay, so if 4 are turned on, we may have a max out of here. So max out of here would be 8 plus 12, 14, 15. So it will be like 15 hours. And here we'll still need to do the combinations. But above, the hour time will be only one solution if all 4 are set. If 3 are set, then we'll have like this 3, this 3. So have a little bit more combination, or 2 only. Yeah, I'll need to write them down. So I'll have like 8, 4, 2, or I have like 8, 4, 1. I think we are done with 8, 4. So next I'll do like 4, 2, 1. And well, so what else do we have? Nothing else. I think there are all possibilities. Because we don't care in which exact order they are. So if they are set, they're turned on, and that's it. Okay, so let's assume we have bits. So we'll draw like 4 bits for the hour, and we will have like 6 bits for the minutes. And we now will need to place our bits. So if it's one above, one below, so we put one here and one here. So one here, one there, one here, one there. Okay, so we have all the combinations. If there are 2, so I'll need to put here combination and start here doing all possible combinations. So that's can be done with like 2 for loops for this and 2 for loops for this. If this grows to 3 and 4, with 4 we have only one approach. We have only one solution, all of them will be set. With the 3, it will be like 3 possibilities above, but below a little bit more. So 9, yeah, actually 209. I guess 209. This I'm a bit confused. Wait a second. No, they are mutually exclusive. It's not like that. It's not like this. So at a point in time, only one of this may be set. Only one bit here, if it's 1. If there are 2, I may use here to set 1 bit and here 1 bit. So it's a little bit more than these combinations possible. Because I can set everything with 8. Can set everything with on the minute side, so this will be like 2. If there are 3, yeah, that's a pretty tricky one. I mean, yeah, let's check the hints, because usually the hint part: simplify by seeking for solution that involves comparing bit counts. Simplify by seeking for solution that involve comparing bit counts. Okay, not sure I got it. Consider calculating all possible times for comparison purposes. Yeah, this I got it. But still, we're gonna need to generate all possibilities. That's for sure not an easy problem. How do they mark it as an easy? Or maybe it has an easy solution and I'm not aware. Okay, so yeah, let's try to do anything. And maybe during coding we'll come up to some plans. Okay, let me close this and let's create a binary watch. That would be a lib cd binary watch. Let's go inside. Zoom it a little bit. Copy this part. Okay, so it will be like a struct solution. And let's add a couple of scenarios. So if one is turned on, I'll have like a bunch of times. Not sure about 9. Why 9 will show like nothing? That's an interesting one. Yeah. Yeah, that's definitely a tricky one. Yeah, probably I'll just do an str for this to compile and work. So I'll have like solution, read binary watch, because I don't want to type here a bunch of two strings. That will be annoying. So if we try to generate all possibilities. Okay, so let me do this at to do. Yeah, this will not allow me to do. I'll need to do it though. It's welcome to Rust. Does it work like this? Oh, it's not implemented. Okay, so I guess first stage, we have our binaries, so our boxes, and we need to put items in these boxes, so like hours and minutes. But we need to be sure where do we put. So one way to do it, it's like to generate all possibilities of numbers of hours, like let's say 1 hour and 1 minute, 1 hour and 2 minutes, 1 hour and 3 minutes, and so on. And then second stage will be to count how many bits are set. And kind of it's pretty possible to do this, because we know that we have like 12 hours, or no, actually we have like 23 hours a day. Will they go with 24? No, it's 23. So we have like 23 hours and 60 seconds, 60 minutes max, or actually 59 minutes. So I can generate all possibilities. So this will be like a for loop from I being 0. No, actually we don't do 0, we do 1, 23, or actually 24. And for j, we do 0. Yeah, this is a little bit trickier because we need to pad it. 0, 50, 60. So I'll be creating my vec of possibilities, which will be like a bunch. And then I'll create a function like to check if how many bits are set for this. And that should be it. Actually, there is a function in Rust called count once, and this will give us the answer. So maybe we don't even need to populate to store it somewhere. I mean, to generate all. So we started by generation of all possibilities of time. And we'll just check the result, and we'll have to work a little bit on this padding issue. I guess, yeah, that may do it. So binary watch. So I guess first step, we start generation of possibilities. Let me write the results here. Let mutable results. That would be a vec, and this will be a vec of strings. And let's return this results. Next stage, let's generate for hour in 0, 24. No, actually we don't start at 0, we start at 1. And for minute in 0, 60. Yeah, we do have 0. Now we'll do the following. F hour count ones plus minute count ones is equaling our turned on. Then we have a solution. Now we need to format it. So I guess what? Ambiguous numeric type. So why it's ambiguous? Use a U32 or whatever. Okay, so turned on, yeah, let it be I32. Wait, I think count 1 returns U size. Yeah, let it be this one, I32, yeah, U32. And this one returns U32. Okay, as U32, wherever, that worked. We'll do like results that push, and we have digitalize. I don't know. Let's create this function, and we'll be passing like hour and a minute. So we'll need to generate this function. Generate digitalize function. Okay, so yeah, let me check a couple of scenarios. So yeah, it's 0 actually. So for hour, nothing fancy. We'll have like a format. Yeah, probably I'll just do format. So we'll have hour, 2 points, and for minute, I think we use a padding. I forgot the syntaxes. I don't know. I think it should be 2 here. Something on those lines. I'm not sure. So hour and minute. Okay, so let's run this. Uh, 16. Wait a second. I think I missed something here. How 16 is 1 bit? No, actually we cannot go like this. Because yeah, 16 it's 1 bit. Because if you go like 24, 16 will be like a 1000. I think like that would be 16. But we should. Yeah, okay, but still we need to go like in that direction. Still we need to go in that direction, and looks like the minute part is not even close. But yeah, we need to start at 0. Yeah, that's the trick. Okay, so now we have like 0 and 10. Yeah, but we don't have 10. Yeah. I feel like it's the right, somewhat the right approach, but I need to tune it up. Oh no, I think the problem is in not correct padding. So padding should be in this, on this side. Okay, so the padding was not right. Okay, this looks more like it, but my problem is with this 16. But wait a second, if all of them are set, if we go with the digital watch, so let's assume all of them are set. Oh, okay, so they have a AM, PM, so max will be like 12. But you cannot do 12 with one bit. It's either 8 and 4. Okay, so cool, now I understood. Fine, I guess, so 12 will be max. Let's go 13 here. And that should be it. I think we solved this one. Yes, seemed more complex than the reality. But let's see if we counted properly. This scenario worked just fine, so let's submit. Okay. Okay, so output and expected. Looks like something though is not right. Okay, so where's the difference? Yeah, let's use a meld for this. So let's have this. Not this. I feel like I don't need this part. Yeah, this is not helping. Okay, so have the first one. So this would be the second one. Yeah, meld doesn't help. So this is what I've got. Okay, so I've got 12. Ah man, this is with the AM PM stuff. Okay, so there is no such thing as 12 because it's either 11 something and then it's where it should be, where I'm something. Oh my god. Yeah, let's check. Okay. Okay, so we solved this. Cool, awesome. So it's the trouble was with this 12. So yeah, now it's clear, solved. We can move on. Binary watch at binary, convert a number to a hexadecimal. I have 2 more problems and I am done. So that's cool. 1A. I don't know, I mean, either it's an easy one or I will spend some time trying to figure it out. Given an integer num, return a string representing its hexadecimal representation. For negative integers, toComplement method is used. toComplement method is used. Interesting. And I have a feeling like in Rust we may try something like this. I don't know, maybe it will work, maybe not. It has. Uh, 26. I just want to check what does it do. h. 26. H doesn't know anything. It's not H. XX. So we have binary. From binary we may try to go, I mean, there is always the old way, counting to 26, but I feel like should be a trick somewhere. Yeah, let's check what's this to complement method. Yeah, unfortunately it's whiteboard. Theory. Yeah, I guess let's go back and try to find rest. No, that's not good. Hexadecimal. Yeah, let's see this. Oh, so it's 0x. Okay, decimal letter is 0x hex string. And how we do a hex string? Okay, so that would be hex string. I knew it should have like a representation. So is that all? I mean, that's really fast. Okay, so let's check. So it's x, the way to go, and it will be 1a. And if we go like with -1, I think it will be a here. F. I guess that's the way to go. I don't know. Num. Yeah. Pretty fast solution. But it was kind of a tricky problem. Is if you look at the submission acceptance rate, this means like pretty much half of the people who started this problem, they didn't get to an end. They didn't know how to do it. But okay. What else? And I think we have the last one, guys. We have the last bit manipulation problem, easy problem on LeetCode. Literally, we solved everything else. And I do not want to buy premium for this one. Maybe next time. So yeah, no other problem. So power of 4. I think I solved power of 2. Because it's quite easy, but power of 4 is a little bit more tricky. And we'll have the following. Given an integer n, return true if it's a power of 4. Otherwise, return false. An integer n is a power of 4 if there exists an integer x such that n equal power of x, 4 power x. I mean, that's kind of logical. Ahead of the curve. Yeah, this one, it's a tricky one because yeah, I'll need to get back to the drawing board. And here and here, power of 4. So if we start drawing like power of 1, 2, and 3, and 4, and 5, let's assume here we have like a 0. This will be 2, 4, 8, 16, 32. 6 will be 64. So this one would be power of 4. This one would be power of 4. How about this one? Okay. It's 2 power 2 plus 3. So 4. Wait, it's not like that. So wait, I'm kind of melding. 5, it's not power 4. So 32 is divisible by 4. It will be 8. But there is no power which we can put here. So 4 power 16. 16 by 4, it's 64. So this would be, and then this would be power 4. So kind of we have a pace, so we'll need to skip 1. So for a number to be power 4, it does need to have only 1 bit set. It cannot have 2 bit sets. So 64, it's the 6th bit set. 16, the 4th or 5th in this case. Wait, this will be 7th. Whatever. Bit at position 6, bit at position 4, bit at position 2, or 0. So we have this chain, and it goes on and on. So next one will be power 8, where this bit, and this will be like a 256, I guess. Yeah, 256. So how can we check? Okay, so first thing which we can do, it's count how many bits are set. So it should be equal to 1. And then we'll need to get at which position it's set. We need to check at which position this bit is set. So how can we do that? Probably we can shift right and increment position until we find our. And once we found the position, so let's assume we found 16. How do I know that 16 is a good one? Because it's divisible by 2. Everything here is divisible by 2. So I guess that would be my answer. So yeah, the algorithm which I'm suggesting, it's counting the bits, checking if it's 1. If it's 1, then we go next stage, we shift right 1 bit, we up till the moment, then we'll find the last bit being 1. And then we found the last bit being 1. We have a counter. And then we check this counter to be divisible by 2. And that should give us the right solution. Pretty straightforward. So yeah, let me try to code this. I will not create another one, and a little bit too exhausted. So fn power of 2, 4. And let's create a test. And let's do like let 16 wherever. So I guess first stage we do and count once equal 1. If this is right, yeah. Okay, so we'll be counting once. So this should be, if this is right, yeah. It's false otherwise, so print line result. Okay, so if it's count 1, then we start shifting right. While n is greater than 0, yeah, this will be mutable. Now we'll need to find the position of this friend of ours. Let counter being 0. Let last bit, and we do and this we found last bit. If last bit it's 1, we do counter, we do kind of here return counter modulo 2 equal 0. Yeah, this will not work. Okay, so else we do false. Okay, so why don't you like counter mismatch type? Yeah, this will not work as easy. Yes, yeah, let's do break. And then here we'll do like counter modulo 2 equal 0. Yeah, but we may exit before actually, and that's a little bit problematic. Yeah, and we'll need to shift right. And we'll need to increase the counter as well, yeah, for sure. So we have these things. We increase the counter. But this doesn't tell anything. We may... Yeah, but the assumption that we have a 1. If we'll not have any 1s, then that will be kind of ugly. So that's true. Let me try a different one. Let me try 17. That's false. Let me try 32. That's false. Let me try 64. That's true. I mean, this has potential. This has potential. Let me try to check it. Result. It's written in a bit different form, like ugly form. Yeah, let me copy it and reform it. I don't like how it's coded. So yes, be something like this. Yeah, this needs to be marked as mutable. Okay. Yeah, that's ugly. I don't like how it's written. Maybe we can do something like this. We do a match and count once. So if it's 1, we do something more. If it's not 1, it's false right away. And here we apply this logic. So we'll not need any of those. And now it looks a little bit cleaner. Yeah, maybe I'll write it like this. Okay, so let's try to run here. Maybe even I can find a way to do it better. Okay, so this works. Awesome. Did we solve everything? I think we did solve no. This one and output true. Wait a second. So it's I32. So what's up with this one? Okay, let me add this test case. Yeah, it's close to the last one. Sometimes I oh, if it's a minus sign, then we'll need to treat it differently, because minus signs, they have like they start with a 1 in binary representation. So let me show you guys. I think here, let me remove this. So let n. So in binary form, this will start with a 1, if I recall. Yeah, you see it's 1 and bunch of zeros. Wait a second, but what would be like a U32? No, I'm assuming that's not correct, but so that's the same. No, something is not right here. Yeah, let me check just simple number like -1. -2. Oh, so everything is 1. Or it's padded with the 1s. So this being the biggest number. So how many 1s does it have? Count once is 1, 1. That's quite tricky. So it is 1. So is it divisible? How can I do it? It's log base 4. I think that's so log 10, log 2. Intrinsics, log f. Natural logarithm. Okay, so this will be the last bit. Okay, so if we go with simple approach, I mean most logical approach, there is absolutely no number at power 4 which can give this one a negative 1. That's impossible. Yeah, so we'll need a number. Okay, no, not like this. 4 power. How can we get a negative number using 4 power x? No, I don't think it's possible because they will be positive. All of them will be positive now. So I'm just thinking like if it's negative, then it's false automatically. Yeah, let me try again. Expected false. Yeah. I mean, that's a hack, but why bother in this case? So use test case, run. Uh, hmm. Oh, so it's correct now. Okay, so let's submit. Okay, so we solved another one. Yeah, if it's negative, then false. If it's n equal 1, return true. Then do all x's. If it's one of them, then return true, else return false. Yeah, it's similar approach. If we do shift right, it's but I'm a little bit stupid. Kind of, I can shift them 2 bits. Because I'm pretty sure, yeah, we can shift here 2 bits, not 1. And that would work as well. And it will be twice as fast. Yeah. So let's make this algorithm twice as fast. But not working. Okay, so n is 4. Output being okay, so we got here probably. Okay, so I'll optimize it next time. Let it be 1. Yeah. Yeah, that's as well a smart solution. So you just do a logarithm and see if this is equal to 0, then everything goes well. Yeah, I'm wondering why shifting to position doesn't work. Yeah, that's interesting. Okay, I think I'm done for the day. I've managed to solve absolutely all problems having the tag bit manipulation. So yeah, everything is done. So we solved quite a lot of problems, and we are done with this tag. Next thing which I plan or I intend on doing is shift a little bit the approach, and mainly we'll be following this guy's approach on learning data structure and algorithms. So LeetCode.io. So he produced like a graph structure where we'll be using like a breadth first search. We'll trying to solve different problems using in this form, like starting with arrays and hashing, and then 2 pointers, stack, binary search, sliding window, linked lists, trees, tries. Awesome. Heap priority queues. So he structured this one, and I've watched the video. He kind of structured this one in a sequential as a sequential learning curve. So these ones are the easiest, and below ones and the most difficult ones here are the most complex. So we have like dynamic programming, backtracking, graph algorithms, priority queues. I used to solve at least a problem from every category here, but I want to try this list. So here will be like the links to LeetCode problems, and we'll try to go one by one. And I think can I mark them as done? Yeah, probably I can mark them as done here, so that would be cool. So yeah, I guess we'll start with this tag, arrays and hashing first. Maybe some of them I already solved, I don't recall, but we'll see. Yeah, so that's the plan for future streams. I'll do it during the weekend. If there are any other suggestions, please write down on the comments. Press like buttons, subscribe. We will learn together, guys. So we'll be good, strong engineers. We will know data structures and algorithms, and we'll forget how to code normal stuff at work. So yeah, okay. Have a nice evening. Bon appetit, Nikita. Wish you a nice evening as well. So bye bye, guys.